So, welcome to all of you in this session of lecture. Here we will be considering diode approximation as our discussion for today's lecture. Where approximations is the most important word, what is to be looked for throughout the lecture session today. From our previous lecture, if you have seen there that we were discussing about electrical circuit analysis using diode as a component to it. For that, what we considered, we saw that one electrical circuit with one resistance R1, obviously unit is ohm, that with one diode, say D1 we named, and it is biased through a DC value E volt or E voltage, potential difference of E volt was applied to it. Then we analyze the circuitry considering diode actual model into it. For that, we had to consider actual IV characteristics of diode, and then also a DC load line we had to draw there, so that we could find the quiescent point or the operating point at which this electrical circuitry is working. I think all of you remember that. So, in that what we did, we considered IV characteristics of diode. If the voltage across the diode varies, current flows through it was IF, that gave these characteristics. This is individually for the diode without any consideration of the load resistance R1 which was connected to it. But since it was a component to this circuitry, to find the operating point, we had to draw a load line there, where we found the 2 points there. One is at E by R1 and another one as E there. What is the significance of capital E and E by R1 current there? It is actually the E potential which we have used there to drive the circuitry, and E by R1 is the current flows through it if diode has potential drop 0 across it. So, the maximum current flows through the circuitry. So, these are the two limits we found there: maximum current with least voltage drop across the diode and complete voltage drop across the diode, and current flowing through it is 0. So, we call this as DC load line, and the analysis we named there DC load line analysis or graphical method, as you remember. Okay. So, in that basically we were trying to consider the diode with its actual characteristics. I will say here actual characteristic, this actual term I am using here purposefully because my topic here is diode approximation, means approximation of that diode characteristics I am going to consider for today's class. So, if I am moving for that, why? What is the purpose or what is the reason for which I am planning to move towards this? Because from the name itself, we are seeing that it is an approximation. If the accurate analysis is there with us, why should we move there for approximation? This is the first question. Actually, if you carefully look into this current expression there, or the DC load line which you have found here, here you are seeing that R1 term is involved in it. Now, if I change the R1 value, this load line will be at different place. Just like if I increase R1 value, just like R2, so it will become E by R2, so another load line will be found the same amount of driven voltage capital E. In that case, the intersection point will be the Q point or operating point for me. So, I am seeing here this circuitry is actually dependent on the external load which is connected to this circuit other than this D1. Now, you imagine if one bigger circuit is there where not only single diode, many diodes are involved in it, or this R1 is different at different position there. So, in that case, it will be difficult for us to analyze those circuits where diode is involved. So, for that, if something is there we can make here so that our analysis will be easier, or it will be easier to handle the complexity in the electrical circuit. We will try for that. So, basically I have nothing to do with this DC line in my remaining lectures there, remaining portion of this discussion here. Only I will be discussing about this D1 characteristics of D1 and approximation of that characteristics curve which is given here in this fashion. Okay. So, let us move to the actual discussion where we will be discussing about diode approximate models. First model I will consider diode ideal model. In this, the important part is this ideal word. Obviously, it is an approximation, as I said from the beginning itself, that here I am modeling the diode such that it will be considered as in ideal state it is working. Let me give the mathematical model of ideal diode, then we will go for graphical representation, and then we will see how the electrical equivalent circuit becomes very simple, where the reference is taken again this circuitry. Okay. So, mathematically if I represent that, say the current flowing through the diode IF, if it is non-zero, or if I say IF I need to get greater than 0, in that case I have to make VDF greater than equals to 0. IF will be 0 else. This is the mathematical model of ideal diode or ideal diode mathematical model. Meaning is very clear that if the voltage across the diode becomes more than 0, then current will start flowing, and if it is less than, then current will not flow. In words, things are like that. Now, if I represent it graphically, what is the graphical representation like this? In that case, I will again plot VDF and IF here. Say I have named this VDF as a forward voltage. Similarly, in the reverse side, I am considering it as diode voltage in the reverse direction, and current flowing in the positive direction is IF, and current flowing in the reverse direction is IR. But we are concerned about only IF greater than 0. So, where will I get? I will get if this VDF is more than 0 volt. For that, I will get a current like this. And if it is less than, then I will see there it is 0. It is going to negative side, to very high negative voltage, and from there you are slowly increasing the voltage, which is the negative voltage across the diode. Now, the time it reaches 0, current will start flowing there. So, can I say that this characteristics is considered here in this form, considering that in the reverse side there is no current. Even though some reverse current you have seen in the actual model, that is considered 0 here. That means as if no current is flowing there. Now, the time it gets a forward voltage greater than equals to 0, current starts flowing. So, now even though some small current is flowing here, still I am considering that current is flowing there. Okay. Now, the meaning of this line which is going vertically there, you can find the slope of it, which is infinity. That means the current which is flowing there just above 0 or just greater than equals to 0, for that voltage current is infinite. Practical meaning is like this: in this kind of circuitry, if the voltage across the diode goes beyond 0, the current which flows, that will be purely decided by the resistor which is connected to it. That means whatever current you want to draw, you will be able to draw through it. Okay. Then why you are not considering the voltages which is beyond this? That may be the question. Now, I will again come to that point, that if the slope is so high that this goes like this, in that case I consider that this is so small that as if like at tends to 0, things are going to very high. Again I will remind you, I am talking about approximation. Fine. So, it is purely an approximation of this curvature, where we are considering that with a small incrementer of this voltage, current will go very high, and with a small variation of this voltage, the current changes very high. So, diode has nothing there to do other than this electrical circuit element which is connected to that circuitry. That is why we say that here in this condition, if the diode voltage goes beyond 0, things will be purely controlled by the external electrical circuit element other than diode. Okay. So, that way we consider this actual characteristics into this form, where our model goes this way. Now, the electrical equivalent circuit, if I consider this electrical equivalent circuit of what? Of this, where the diode is connected in between. So, if I find that VDF has gone beyond 0 or it is beyond this, then this complicated circuitry I will be simply representing as short. Why it is so? Because I am saying here that if it is just touching 0, then current will go very high. So, what is the voltage drop across the diode? It is 0. It is meaningless to talk about the voltages which are beyond 0. The small incremental value will change the current like anything. So, as if like voltage drop across the diode, if it is 0, we are considering. What does it mean? It means purely a short circuit. That is why I could represent this D1 in this fashion using this diode ideal model. Now, if I want to find the current here IF, I think it will be simply E by R1, as I said earlier also. So, I do not need to go for further analysis of DC load line to draw, find the Q point, nothing. Obviously, since it is an approximation, we have to pay something somewhere to get the accurate value of it. But it works in many electrical circuits there with this ideal diode, where a complex circuit will come there, where the accurate voltages are not that much matter to us. Okay. So, let us move for another approximate model, which is called constant voltage drop model. I'll take the same way for representing this approximate model, the way I was representing the diode ideal model. So, first the mathematical model. IF greater than 0, when if and only if VDF goes greater than equals to some voltage Vf. Sometimes we call Vf as cut-in voltage also, but no need to consider at this stage that is a cut-in voltage always, but take one constant voltage Vf there. If VDF goes beyond that voltage, then I will consider that current is flowing through the diode, and less than that, if it is, then If is equals to 0 else. Okay. So, if this is the mathematical form, then graphical form also should be something there like VDF IF. Now, if I say current is high after Vf, let me first define the voltage Vf somewhere. Now, the characteristics what we considered earlier, that was having the current at 0 itself, now it is at Vf. So, if I consider the voltage is less than Vf, then current is 0. What is the difference of this model than the ideal model what we considered earlier in terms of approximation of diode characteristics? I am telling. It is like this. Earlier we considered that current started at this place itself. Now I am going towards more accuracy, like no, current has not got that much significant value at this stage, but after some time if you say, maybe that is fine. Up to this the current has not gone that high. After this the current which is there, that is significantly high. So, if that is the voltage Vf I have identified, that voltage I am talking about here. Okay. So, I will consider now onwards that after Vf, current through it is whatever current you want there to draw, that is allowed, but beyond that it is 0. Okay. So, now if electrical equivalent circuit of this diode we want to represent, then this is the diode D1 what we found there. So, that if I represent in terms of ideal characteristics or ideal diode, what it is here, if current goes beyond 0, this diode may become short, but because of this potential here which is behaving as plus Vf voltage here. Now, if here it is plus minus Vf voltage, what should be the current? E minus Vf by E minus Vf by R1. This will be the current flowing through it as If. But if this the voltage across the diode VDF what we have considered here, if it is less than Vf, then no current flows there. In that case, things are open. So, that means the external voltage is not driving the diode beyond its constant voltage drop which is required for the diode first to start working. That is why the name of this model is given as constant voltage drop model of the diode. Fine. So, if this equivalent circuit is now placed to this place, and for that the current we have found here as E minus Vf by R1, I think it is much more simpler than the DC load line analysis and its Q point finding. Again I will remind, it is again an approximation which will not be there that accurate like we were getting for the DC analysis. But my try is to move towards that. Okay? So, we will go for another model there which may be much more accurate in terms of actual characteristics of the diode. Now, here one thing you should not miss here, that I am representing this electrical circuit in terms of ideal diode, where after I see that things are getting conducted here, this electrical circuit will be considered as R1, then it is short, then one potential drop has come as plus minus Vf. This is the diode. Okay. So, things are represented in terms of ideal one, because we need always somebody should be there with reference to which remaining thing will be defined there. Okay. So, for that only this ideal part has come into it. Okay. So, let us move to the another model. It is piecewise linear model. In this, we will consider that if diode current is flowing there, in that it has to cross a particular voltage level there, and then the flow of the current through it is not whatever current you want, that will be decided by the external load there, but also by the diode also. Means diode also will have some control over that current which is flowing through it. How it is? Let us first represent it mathematically. So, If in this case, I will not say like earlier that greater than 0, I will say E minus Vf by Rd if Vdf greater than equals to Vf. Again, this Vf is diode forward voltage, as a reference it is considered there. Later I will change the form of this Vf to another value where multiple values will be seen there, but at the beginning you please be with this one. If equals to 0 else. Mathematically I could represent the model. Now I want it graphically to represent that same way we were doing in earlier case. If this is the scenario, I am seeing here, if only one resistor would be there and Vf would be 0, then it would be a linear curve with a slope 1 by Rd. But I am seeing here the origin has got shifted to Vf value. So, it is a one straight line there, but it has started from Vf with a slope. How the slope is decided? Delta V by delta I, that is Rd. So, this Rd is related to this slope, decides the Rd value. Okay. Now, if this voltage Vdf or voltage across the diode is less than the Vf, then things are 0, no need to consider for that, diode current is 0, circuit is open there. But if it is beyond that, in that case you have to take a particular route through which you will see the increment or enhancement of the current will be found in the circuitry depending on the diode internal resistance RD. If I am saying about diode and its resistive action there, so I can consider that in the equivalent circuit I have considered some resistance there for the diode itself. So, if I consider the equivalent circuit there, that electrical equivalent circuit what we said earlier, where this was the block in which first one ideal diode will be there, another part was there just like earlier plus minus Vf, along with that one resistance has come, that is RD. What is the difference from the second model where we consider constant voltage drop only without any RD? In that case I will say RD is 0, otherwise remaining things are same. Okay. So, if I want to find current flowing through it using the diode model as piecewise linear model, what should be IF there? Now IF will be E minus Vf by R1 plus RD. So, involvement of RD is there. What is so great in it? I will say it is much more better model compared to earlier where they were not considering at all this slow rising of the current there, but here at least it could draw a line like this, which is average line, and some points of the actual characteristic is in the left hand side and right hand side, or this line is passing through a average locus. Okay. So, that way it is much more accurate than the earlier. How we could do this? Here we have made the actual characteristics in small piece, and then some part we have considered as a current 0 and some part we have considered is rising. Name will be much more clear if I go some small extension to this one. Like I do not consider that this curve, piecewise linear curve, is of this kind, but better approximate curve like this. I think it is better appreciable by you, which is going towards this curve, which is my main aim to reach. Okay. But here also, see here, I have considered up to this some voltage Vf, say named as Vf1. Another is there, here I am seeing Vf2. Fine. Now, if I want to mathematically model this part where the total curve has now represented in terms of small pieces of it. So, here I will mathematically I will represent in this fashion that if voltage drop across the diode is greater than 0, but less than Vf1, VDF or if VDF like this, if the voltage VDF, voltage across the diode is more than 0, but less than Vf1, in that case the current flowing through it will be E minus Vf1 by if it goes beyond this, that means the slope related to here, it is RD1. Then if I consider another VF2 there, then I have to consider that the voltage across diode should be greater than VF1 and less than equals to VF2. So that will tell me about another resistance RD2. Okay. So, and if VDF is beyond VF2, then another resistance RD3 it can come. That way, I can find that the total curvature here, that can be represented by this circuit itself, where this VF will not be a constant VF, but sometimes it is VF1, sometimes VF2, sometimes VF3, and this RD will be sometime RD1, RD2, RD3 like that. Okay. But for that I have to track that what is the voltage coming across the diode. Is it within this range or within this range or within in this range. So that means complexity in your system analysis is becoming more, which is quite obvious, because you want to get a better accurate value there. Okay. So for that, how many RD you can consider there? I think multiple number or n times, n numbers, as more as you can afford in your circuit analysis. Okay. So now if I make this approximation or piecewise linear approximation of this actual curvature, which we considered at the very beginning, now you consider a small section of it. Are not they linear line? Straight lines for the small region, or the nonlinear equations. Don't we solve the nonlinear equations by considering a small part of it as linear? This is a purely mathematical approach of solving nonlinear curvatures, or it is also there to devise the systems which are nonlinear, considering them linear with this kind of concept here. Okay. But only thing is that we have to go for, we have to afford that extra cost there. Still, if you are not satisfied with this model in terms of accuracy, I am saying, you do not have any other choice than DC analysis, what we did earlier, or DC load line analysis at the beginning, what we did. So in that case, we have to draw the load line there, find the Q point, so that you get the actual one. So in this lecture, actually I had a plan to make the diode approximations or models in diode, considering diode approximation there to the actual model there, so that you can travel any place wherever you like. If some accurate values there, in that case you will be moving towards piecewise linear model or up to DC load line analysis, or if you want a quick analysis of the circuitry, then you will be moving to in the other direction, where in ideal case you can consider that it is a voltage. If it is more than 0, it is current is flowing. If it is not, current is not flowing there. Okay. So now if this kind of diode circuits are there, let us see what applications basically these diode circuits are there. One small example we will take for today's class. This is one application of diode in electrical circuit, where the circuit is named as clipping circuit. Series is for different reason, that where we will be connecting the diode in series form. But clipping is most important word here, which is considered. What do you mean by clipping of something? Actually, in terms of electrical waveforms, what we will discuss here, that is, if one electrical waveform is given to you, you want to clip off some part of it. Clip off some part of waveform. Sometimes we call this circuit as limiter also, or we will consider this kind of circuitry is used for limiting the voltage which will be going to my bigger device, which can harm the system. Just like I have option to apply the voltage up to 10 volt, not beyond that. If sometime because of any reason the voltage fluctuation is going beyond that, that can harm the system or burn the system, in that case I will limit it. At any condition it will not go beyond that particular voltage there, which is generally used in the computers also. Okay. So, this kind of circuitry, if we want to develop by using this diodes along with one resistive load, please name one circuit there which is named as negative clipping circuit. At the end, I will ask you what is it basically, which is already known by you. Say, this is an electrical signal or one wave shape for electrical signal is presented here, where this is the 0 voltage level, where it has gone up to plus E volt to minus E volt. But I am interested to pass only this positive portion and clip off the negative part. So, for that the wave shape what I want that should be like this, where it will be going for positive, this is 0 volt, for the negative part it will be clipped, then again it is 0, then at this place again it will be like this, then go. What is about the negative part? That is clipped off. This is my desire. So, I want to implement one circuitry for that, which diode can easily do. I think something is coming in your mind, that we will have a diode like this and one resistance will be connected here R1 this way. Here we will be applying the voltage Vi, which I have mentioned there, and some voltage I will get across the load V0. So, this is D1 diode which has positive negative conventions are this way. Now, if I want to analyze this, if the voltage goes beyond 0, then considering diode ideal model there, the voltage whatever it requires there, it will be coming to it. If I consider diode ideal model, if voltage goes beyond 0, in that case I will see this equivalent circuit is just like short. So, what is the output voltage? Purely this VI what I have applied, what is that? Plus E. So, I will get plus E there till this point. Then the time it goes to the negative, that means less than 0 volt in the diode. So, that is open circuit, no current is flowing into it. What is the voltage there? 0. So, this circuit can easily do this part where this negative part of it can be clipped off. So, this will be called negative clipping circuit, because it is clipping the negative part. Fine. Now, if I ask you for positive clipping circuit, I will use the same. What is the change to be made? The diode is to be connected in other way. In that case, I will say this part is clipped off and this part is there. So, in that case, the voltage I will get there like this, where what is the 0? 0 volt here as reference, and what is the voltage at the peak? Minus E. That means these two parts are gone there and they are existing. Now, since here positive part is clipped off, I will say positive clipping circuit. Now, since the components are connected, the diode is connected in series with that load resistance R1, I will call it as a series clipping circuit, because we are going to discuss the shunt clipping circuit also in the later class. Okay. One more small incremental discussion towards this. Which is very frequently used in many electrical circuits or for many applications there, where the noise is a part along with the actual signal which we handle. So, in that maybe we will like to clip off the noise part, that can be either positive or negative. Which way? Let us take one example. Say this is the signal, where one peak has gone up to plus E, another peak has gone up to minus E, and this is the 0 level, which is the average one, and in that I am seeing some rippling of the average level is happening, even though signal was not supposed to be. So, this is the noise part I have identified. This small up and down in between, which is supposed to be a 0 flat line, I want to clip that off. So, for that I need to find what is the maximum voltage and minimum voltage of this. So, if I find that this maximum up and down of this with respect to this 0 is plus minus Vf, say noise is plus minus Vf for example, that I want to clip off now by using a circuitry. How it will look like? It will be circuit should be like output voltage should be like this. Where this small up and down plus minus Vf is now gone down. To implement that one, this kind of circuitry you can try. plus minus Vf plus minus Vf. This circuit will nicely do this job. How it is? We have to explain. See here, these diodes, two diodes D1 and D2 are used in such a way that if the voltage goes beyond plus Vf or beyond minus Vf, then only some current will be flowing to the R1 and voltage drop V0 will be found non-zero. Otherwise, it is 0 if I consider that this is say grounded, which is at 0 volt. What is it? If it is a positive peak, if I consider, say this voltage has gone from 0 to this part, which is plus Vf, till it reaches plus Vf, the output voltage will be always 0, because no diode is there to conduct that voltage, conduct the current through it due to that voltage, because it will be forward biased or it will be in a condition to give you current only if the voltage across the voltage here you apply beyond plus Vf. After you apply plus Vf, then this is in conducting mode, nothing to think about the other side, which is already in reverse bias. So, no current will be flowing through it. So, for this part current will be flowing and finally voltage will be found across the R1. Now, if you go for the other side here, for the negative part of it, in that case this part may not be following, may not be responding for your negative voltage, but this is there for responding to the negative voltage, but still it needs a plus Vf minus Vf voltage to operate it or to allow the current to flow through it, so that you get some voltage through the voltage across the resistance R1. So, if some negative voltage is applied like this, which is beyond minus Vf, those will be giving some current there, but less than this, nothing will be flowing either through this or this. So, output voltage will be 0 there. So, that way this clipping of the noise can be done here. That is why it is called noise clipping circuit. Now, on small incremental thought, I will give it to you, like if this diode D1 and D2 has Vf1 not equal to Vf2, what happens to this? Or if I say that across this 0 voltage, if the noise goes more in the positive side and less in the negative side, or more in the negative side, less in the positive side, for that I need to design a circuitry like this where noise will be clipped off. What to do for that? Please do practice for that, and up to this only we will take for this lecture. Thank you.